Okay, guys, so I just want to go ahead and recap of what we did this past week. So the first thing that we did the central limit theorem for means, right? So this is what we did first on either Monday or Tuesday. So basically what we did, this was a simulation, and I was able to simulate the population, and I got samples from them, right? And what I did, I was grabbing samples. I added them all together and I divided it by the total. And then in the end, what I ended up getting was the distribution for the mean, right? So this is the sample mean, right? This is sample mean, right? And I wanted to know, what does the sample mean look like? And what we discovered was that it was normal with a mean that was exactly the same and a standard error of sigma over square root of n, right? Now, I think for one of my Tuesday class, I didn't say the requirements. I ran out of time. So what you need the data to be normal, right? So in order for me to use a central limit theorem for means, I need to make sure that my data itself is normal, right? So the size of n does not matter. If n does not matter, it doesn't matter how big my n is, right? What matters is that my data is normal, okay? Then let's say my data is not normal. Well, if my data is not normal, like let's say if it was skewed or it was some other type of distribution, I just need my n to be greater than 25, okay? Greater than or equal to 25. If it's not greater than or equal to 25, right, then in that case, I cannot use the central limit theorem. Okay, so that's the only thing that I forgot for one of my Tuesday classes. Now, central limit theorem for proportions, what we had, this is the activity that we did. We were rolling dice, 10 dice, and we were looking for the distribution of all of our sample proportions, or the distribution of even numbers. What we found was that it was normal with the mean centered at P, which is what we believed from the very beginning, and our standard error is this. The only requirements is that we require NP, the multiplication of NP, to be greater than or equal to 10, and the multiplication of n times 1 minus p to be greater than or equal to 10. Okay? If you see hear a squeaking sound, it's because I am dog sitting and the dog is biting. Okay. Anyways, so if these two are not satisfied, then you cannot use it. Okay. All right. So that was just a little recap of the central limit theorem. Some examples can include the following. So let me just give an example. Well, before I do the example, right? Remember, when do we use this? So when do we use it? When do we use it? So remember that if you have a population, right? Let's say that's my population, and let's say I took a small sample. So once I take a small sample from the population, that's when I'm gonna start using the central limit theorem, right? So I took a small sample, right? If I take a subset of the population and I want to find the probability of this sample, right, then in that case, I'm going to go ahead and use central limit theorem. Okay, so let me give you an example. So let's say I want to use central limit theorem for means. So I want to use CLT for means. Okay, let's say I had data and my data looked like this, right? My data looked something like this. I don't know, that's what my data kind of looks like. Okay, and what I got 23 samples. Okay, can I use central limit theorem in this case? Can I use it? Can I use it? Well, let's go ahead and go back to the assumptions, right? Well, we need to make sure that our data has to either be A, normal, or not normal, but n has to be greater than 25. Well, this clearly is not normal, right? This is not normal. So we need to make sure that n is greater than 25. Well, in this case, it's not greater than 25. So can we use it? No, we cannot use it. Okay. Now let's say instead I have my data to be normal. My data in fact is normal, but n equals 10. So can I use it or can I not use it? Well, let's go back to the requirements, right? We have that the data is normal, right? But notice that n is less than 25. So what should we use? Well, remember that's why I wrote this thing in parentheses, right? N does not matter, right? It doesn't really matter what n is, right? What we have, as long as it's normal, the normality of the distribution of the original population overpowers the fact that n is really, really small. So this one you can use it. So say yes, it is normal. It satisfies the first one. So I just wanted to recap a little bit of what we did. This part will not be on the exam, but I do want to have a video so that you can just go ahead and go back and be able to to view it and remember what we did. Okay.